In 11.3, instead of us telling you that lines are parallel, you're going to prove that lines are parallel. So in order for you to prove that lines are parallel, you're going to need to know 3 theorems and 1 postulate that prove lines are parallel. A theorem is something that is widely accepted as something that has been proven by some mathematician way before your time. A postulate is almost the same thing as a theorem, except it's not as solid, even though it is accepted. So think of a postulate as something that is acceptable. It's in the A- category, whereas the 3 theorems are in the A+ category. Does that make sense to you? What you really need to know, don't even worry about that. You're going to need to know what those 3 theorems are and the 1 postulate are. So let's write those things down. Here's the first one. Alternate, interior angles theorem. Let me zoom in a little bit. This is our first one. The alternate interior angles theorem. What this one says is it says that if the alternate interior angles are congruent, then the lines are parallel. How do I want to write that? If alternate interior angles are congruent. If alternate interior angles are congruent, then they are parallel. That's what that first one says. Draw a quick picture. Alternate interior angles. Which ones are those? They are the ones that are on the inside, and one has to be on one side and the other has to be on the other. Did you already go to room 113?
Yeah, I finished.
Perfect. So this is what it says. If these 2 alternate interior angles are the same, then the 2 lines are parallel. There's one other way that it could be. It's not just this way. It could also be like this, where the big angles are the same. If the big angles are the same, then the 2 lines are parallel. Those are the alternate interior angles. What we discussed way back in section 1 was that alternate means on alternate sides of the transversal. Interior means in between the 2 lines. The second theorem is alternate exterior angles theorem. If the alternate exterior angles are congruent, they are parallel. Alternate exterior angles theorem. If the alternate exterior angles are congruent, then they are parallel. I should probably put a then in there. because it's a hypothesis and a conclusion. So I'll give you another quick 2 pictures. Just a quick sketch. Quick sketch. Alternate exterior. One's on one side. Exterior means on the outside of the 2 lines. The other one's on the alternate sides. If these 2 are the same, then the 2 lines are parallel. That goes for the skinny ones too. If this one is the same as this one, those are alternate exterior angles, then the 2 lines are parallel. The third one is called the corresponding angles theorem. If the corresponding angles are congruent, then they are parallel. If you've forgotten which ones are corresponding, they're on the same side. One's on the interior, one's on the exterior. I'll give you an example. This angle here and this angle here are corresponding. It can also be this angle here and this angle here. It's the one that skips a space. This one's interior. Skip the other interior and go to the exterior. One's interior, one's exterior. Corresponding angles theorem. That's the third theorem. And there's one postulate. Same side, interior postulate. If same side interior angles are supplementary, which is different than we've done before, then they are parallel. Scrolling up a bit. If I know that this is 60 degrees, oh, that's not even correct. If I know this is 60 degrees and this is 120 degrees. Same side interior postulate. They're on the same side. They're both interior angles. If I know that 60 and 120 are supplementary, do those add up to 180 degrees? If they do, then these 2 lines are parallel. These are the 4 reasons that you can use to prove that any 2 lines are parallel. And so I want to give you some examples that are in your that are on your worksheet so that you kind of have a clear idea of how this thing is going to work. I'm going to do number 2 with you. Let's write down number 2. Number 2 looks like crazy 2 triangle thing. This one. Yeah, my pen's not liking me right there. Oh well. Sorry. ABC, DE, and then this is 40 degrees. This is 40 degrees. This has an arc, and this has an arc. And the directions say which lines or segments are parallel. Which segments are parallel? Logan? A, B, and CD are parallel. How come? So let's write that down. His answer, AB, segment AB, so I'm going to put a little bar on top because that's the segment we're talking about, is parallel to CD, but we have to give a reason why. Why are these two things congruent to each other? It's going to be one of these four reasons. So we have to recognize which one is which. If you have trouble with that, let me show you how I do it. What I do is I say, okay, we're talking about this one and this one. They're connected by this transversal. I know that this angle is 40 degrees with the transversal, and this angle is 40 degrees with the transversal. You're going to have to use, here's my secondary pin, something that deals with this 40 degrees and that 40 degrees. If you can tell what type of angles those are, you will know which theorem it is. Logan, go ahead, see if you got it. Do you agree, Ray? I was actually talking to that Ray right there. Raymond. There you go. Raymond says he believes these are corresponding angles. You are both correct. How come? It's called the corresponding period angles theorem. I'm going to put a dot after TA, so I'm going to abbreviate it, which is totally fine. Corresponding angles theorem. Perfect. That's a great answer. That is using the 40 and the 40. There's another set of parallel segments, though, using these arcs. Go ahead, Ray.
B is D because the arcs are on our...
You need to be more specific. We don't just say B. B is an angle. D is an angle.
Okay, BC and D.
Okay, BC is parallel. Wait, let's put a segment bar on top. BC, segment BC. Now we're being really specific. Now you're going to make your Math 2 teacher much happier because you wrote it as segment BC. Is parallel to which one, Ray?
Segment DE.
Segment DE. Now we're being really specific. I like that. And now we have to give a reason why. What do we know about these two angles, BC, DE? We have these two that are the same. What type of angles are they? Which theorem or postulate are we using?
Corresponding angles.
Do we agree? Corresponding angles theorem. It's the same reason why they're both corresponding. That's all you have to do on number 2. Which segments are parallel and how come? Bless you. Which segments are parallel and how come? Do not just go off of, oh, it looks the same. You can't say that. You have to give one of these 4 reasons why something is parallel. You're also going to have to solve problems just like you did before. On number 7 and 8, you're going to be solving for x. So I don't know if you need an additional problem like that. So I'm not going to give you any more like 7, 8, 9, and 10. But you'll have to use those things. Ooh, that one's nice and tricky. Let me do number 10 with you. Over. Let's do number 10. As I look at it, I go, oh, we gotta look at the harder stuff. Hands down, hands down. Don't need a volunteer yet. Let's draw it out. A, B. Then they have this one that kind of goes that way. And they have one more going that way. And are those labeled? No, they're not labeled. What they do have is that this angle over here, they'll draw an arrow to it, is 3x. They have that this angle is 12x. Thank you.
Thank you.
And then lastly, they have a 6x right here on that angle. Number 10 says, find x that will make A parallel to B. Oh my, that's so crooked up there. Goodness gracious. Oh, that's better. Nice and straight. Find x that will make A parallel to B. Yes, Ray?
So I think that 6 and the angle like underneath the line, like it's right there. There's no like letter. Yeah, go down. No, it's like straight down through the transversal. Yeah, now to the left, right. No.
Like go up and point.
I'm just kidding.
Go ahead.
And 6 over here.
You cannot use this 6x over here
Why not?
because it has nothing to do with this A and this B. So let me give you a hint as you're doing these problems. This 6x, yes, we have a transversal, and this angle here is not created with the two lines that we want to prove that are parallel to each other. When I look at this A is parallel to B, A is parallel to B, I need to use a transversal that all the angles are used touching A and touching B. Let me show you what I mean. Is the 3x, is that angle created using one side using line A? It's one side line A. Okay, let's look at line B. Is 12x made from an angle with one side as side B? Now what about 6x? We have this line and we have this line. Is it made or created by one of the lines that is A or B? If it's not, guess what? That tells you you're not going to use it. It's there as a distractor. Do not feel like you have to use everything. What I would do if I were you is do exactly what we talked about before. If this angle here is 3x, the one I'm pointing at, then that means the top right is also 3x. Agreed? Because they're vertical angles. Now let's slide down this transversal and let's skip this one right here and let's keep going down the transversal, bottom left, top right, right here and right here. This one is 3x. The one I'm pointing at is 3x. Let me write those things in there. This one is 3x. This one is 3x. As I was helping out a student over there, are these the same? Are they equal to each other? Are they congruent? They are, starts with an S. They're supplementary. These add to a straight line. These add to 180. So the only thing you really have to do over here is 3x plus 12x adds up to how much?
180.
Let's combine like terms. What is 3x plus 12x? Use the division property of equality. What's 180 divided by 15? You don't know? I don't know either. Oh, look at that. My calculator told me as well. My calculator agrees with you guys. 12. Now, the question said find x. This time we found x that will make A parallel to B. I have the x is 12. Sometimes you're going to have to plug it back in. Almost always you'll have to plug it back in. Here we don't have to. Okay? So that's a harder one. Let's stop our notes right there.